Now we are going to use our graphing calculator to obtain some binomial probabilities. So say we have a situation, or we have a case in which the probability that any person will have an adverse reaction to a certain drug is 0.02. Okay, so we would like to see that if we administer this drug to 56 people, all right, and want to apply binomial distribution, then we are assuming that the drug reacts on each person independently. Okay, and for each person we are looking at one of the outcomes, actually only one of the two outcomes, reaction or no reaction to the drug, and the probability of the reaction is 0.02. Now say we would like to obtain the probability that nobody has a reaction, or the number of reactions is 0. Okay, then we are computing the binomial probability that n is 56, that is the total number of trials is 56. The probability of reaction in any trial is 0.02, and the number of reactions is what? 0. Okay, so what we have then is we will use our calculator and use this feature by that binomial PDF in the following manner. Just look at the calculator, go to second distribution. We are looking for binomial distribution for a particular value 0. Okay, so it's called actually probability density function. So we are looking for the probability of this particular value 0. So we'll choose this binomial PDF. We'll enter the total number first, then enter the probability second, and then the number of successes third. So what our answer is then? 0.3326 approximately for the probability that there is no reaction, or nobody has any adverse reaction. Okay, now let's go to a different scenario. Okay, that is, we would like the probability that exactly one person has a reaction. So what will change now? This 0 will change to 1. Now you can go back to this option by repeating second distribution, or you can do this, press second, enter. Here are your arrow keys. Change this to 1, and the answer is 0.3687 approximately for this situation. Okay, so now let's see, we would like to find the probability that exactly two persons have a reaction. Here I have a typo. I'll change it. So just let's keep it for, like this for a moment. So we want to change, we want to compute the probability that exactly two people have a reaction. Then we are computing this probability. So what we do is we just go back to this, either via second distribution or via second entry. Once you get faster with this, you can do it faster. So the answer for this is what? 0.20691. Okay. Now we answer the question that the probability that 3 or more will have adverse reaction. Now this event is complement of this event. 3 or more is complement of 2 or less. And the probabilities of complements are related in this manner, that the probability of 3 or more will be the probability of 1 minus 2 or less. Now, probability of 0 or 1 or 2 will be the sum of their probabilities. So here we can get these numbers the way we have these here, add them up, subtract it from 1, and we get that the probability of 3 or more will have adverse reaction equal to approximately this number. Now you can do it directly if you want. See, The probability of 0 or 1 or 2 is cumulative probability of 2 or less. So if you are computing it using using your graphing calculator, then you can just scroll down, or you can even type the letter B by using alpha. Okay, but let's just go slowly and methodically right now. So now we have how many? 56, comma 0.02, comma 2. So we will have the same number as we have here. Okay, and then in that case you can just do it directly if you want. Okay, and you can see these two numbers match. All right, so if you have any questions, just contact me again. Hope this works.